let's take a look at y equals mx plus b. So this you probably recall from grade 9. It was in our linear relations units where we talked about a line, and that's what this represents. This represents an equation of a straight line and all the different properties that it holds. So let's take a look at this. Okay. We're going to actually begin today with just graphing. So how to graph these lines if you're given an equation. To begin with, just the bare basics here, we have this m, this number that's going to be in front of our x variable, and this is going to represent our slope of the line. So this is our steepness of the line. If your slope is positive, then your line will be going up. If your slope is negative, the line will be going down. Okay, so the positive and negative represent the direction, and then the number itself represents the steepness of the line. The larger the number, the steeper the line will be. And then B, this is our y-intercept. So this is where the line will cross on your y-axis. That's what an intercept means, that where it intercepts it. So it's our y-intercept, it's where it will cross on the y-axis. Just for a little bit of more information, this x is our independent variable. A variable that does not rely on anything else. And this is our dependent. The y is our dependent variable. And of course, our dependent variable depends on what's going on with our x value. So that's just a few of the basics to get us started. All right, so when we graph, what we want to do if it's given to us in y equals mx plus b form is we're going to use our slope. So our slope in this case is the number that's in front of your x, which is 2/5. And your top number represents your rise, and your bottom number represents your run. And then the number at the end, that constant number right there, that's your b value. That's your y-intercept. In this case, my y-intercept is 1. All right, so to graph this, what you want to do is you actually want to start with your y-intercept. So this is where we begin. This tells me I have a y-intercept of 1, so I would go to 1, and I put a nice dot right there, right on your y-axis, right where it intercepts it. And then from there, I would use my slope. So my rise is 2, which means I'm going to go up 2 from the red dot. So starting at the red dot here on my y-axis, I'm going to go up 2, and then my run is 5. So this is going to be up and then to the right, okay, because they're both positive. So it's up 2 to the right 5, and I get right here. And then once you have 2 dots, then we can easily draw a straight line that cuts through both of them. Okay, so then that would be our equation of the line. So this is A. All right, let's try this again. So let's try this one. So let's say I told you this is B. So y is equal to -3/2x plus 4. Maybe I'll do this one in green. So again, I'm going to pull out my slope. The negative, if it's right at the middle or if it was on the bottom, it doesn't matter where the negative goes. I always like to put it on the top. It's kind of where my preference is. So -3/2 is going to be my slope. My y-intercept is going to be the constant at the end, which is 4. So I'm going to start at 4 then, right here on my y-axis. Now, because this is a -3, I'm not going to go up 3. I'm now going to go down 3. So that's why I always like to put the negative right there with a number, so it allows me to see exactly where I'm going. So in this case, I'm going to go down 3, and then I'm going to go to the right 2. And that's where my next point will go. And then again, I can draw a nice straight line through those 2 points. That's B. Yeah, so that's all you need is just 2 points to draw a straight line. So let's try C. Okay, so C is a little bit different here. Maybe I'll do this one in blue. I have a slope, and this time it's just 4. So it gives me a rise, but it doesn't give me a run. But that's okay because the run's actually there. We can put any number over 1 and it stays the same. And then in this case, my y-intercept is at -6. So I'm going to start at -6. There is my dot. And then this tells me I want to go up 4 from there and then over 1. Ooh, this is a pretty steep line. And from there, I can draw a line through both points. All right, let's keep going. Doesn't seem too bad. Oh dear. Y equals -7. Y equals -7. Okay, so notice we just have the constant, and what we're missing is that number that's in front. So let me do this one maybe in purple. Okay, so we're missing our slope. So m equals, it's not there. So if it's not there, it's a 0, okay? No slope. But I do have a y-intercept, and my y-intercept is at -7. So that means if I go to -7, I have a slope of 0, which is a horizontal line that cuts right through it, okay? So horizontal line right through where y equals -7, just like the equation, y equals -7. So right through there. This would be D. And then the last one is E. Oh, this one's even weirder. So this is x equals 4. X equals 4. Now that looks very strange, I will also admit. Yes, definitely, because it's not in our y equals mx plus b. So when you get an x equals, there's no y there. This tells us that our slope is what we call undefined. Okay, so it means that there is no slope to this. It's not 0. There's actually, we cannot tell what the slope is. And that's because the slope is so large, it cannot be defined. It's the largest number in that we can possibly think of. And of course, we don't know what that largest possible number is. I do know an x value, though. I know an x value at 4. So this is not a y-intercept. This is an x value. All right, so let me go to x at 4, which is right here. And what this creates is a straight line up and down. So this gives me a vertical line. Okay, vertical line. So if you have a y equals a constant, this is a horizontal line. Whereas if you have x equals a constant, then this is a vertical line. Awesome. All right. But what if it's not in y equals mx plus b form? So that's, of course, always a concern. I can't tell my slope. I can't tell my y-intercept. Well, we're going to have to rearrange first, just like it says here. So let's divide by 3 and divide by 3 and divide by 3. So everything's going to be divided by 3. 3 divided by 3 is just y. 2 divided by 3, well, let's leave that as 2 divided by 3. We have an x plus 6 divided by 3, which is 2. And now look, this gives me my slope at 2/3 and my y-intercept at 2. So 2 is here, and then up 2/3 would be right there. And then I can draw a line that goes through that. Let's try that again. Okay. All right, so let's move this 5x over to the other side. So 2y, -2y can stay here. And I'm going to subtract the 5x and subtract 5x. So that gives me -5x plus 8 now on my right-hand side. And divide by -2. And everything's going to be divided by a -2. So that gives me y equals, because -2 divided by -2 is 1. -5 divided by -2 is going to give me just a positive 5/2, because of that double negative, of course, means positive. And 8 divided by -2 is -4. So I have a slope of over 2, which is great. And I have a y-intercept at -4. So -4 is down here. My slope tells me I want to go up 5 and over 2, right there. And then I can draw my line that I totally missed. There we go. That's at least a little bit better. Okay. Perfect. All right, so if you're not given the expression in y equals mx plus b, that's okay. Just take a few minutes and rearrange it so that you get your y all by itself on one side, everything else on the other side. And then from there, you can pull out your slope and you can pull out your y-intercept. Cool. Now, another way we can graph, instead of using slope and y-intercept, is we can use our x and y-intercepts. So x and y intercepts tell us where the graph crosses on our x-axis, and it tells us where it crosses on our y-axis. And that will give us 2 points, which is great. Usually when we have the form kind of written this way, like x and y are on one side and the constants on the other side, that is when we would think about using intercepts. So let's start with finding our x-intercept. If I want to find my x-intercept, I'm going to let y be equal to 0. So this is a little bit of substitution. I'm going to go into my equation, and wherever there's a y, I'm going to put a 0. And I like that because it just cancels that part out, leaving me with 5x equals 15. Divide by 5, divide by 5, x equals 3. So I have one of my intercepts right there at 3, right on my x-axis, x equals 3. To figure out my y-intercept, I'm going to let x be equal to 0. So I'm going to do the opposite. And wherever there's an x, I'm going to put a 0. Again, this works out really nice because it takes away that term, leaving me with 3y equals 15. Divide by 3, divide by 3, and y equals 5. So y equals 5 is right here. And then I can draw a line that cuts through those 2 points. And do a great job on that line, but there we go. Okay. So whenever you're finding intercepts, it's just a matter, because it does cross on your actual axis, it's just a matter of letting your other variable be equal to 0 and to solve. So if we try, let's say this one more, notice we have all our terms on one side. That's okay. I'm going to start by letting y be equal to 0 so that I can figure out my x-intercept. And I get 3x minus 4 times 0 minus 18 equals 0. So that goes, leaving me with 3x minus 18 equals 0. Of course, I have to solve this equation. It's just a little equation. I'm going to bring that negative 18 to the other side by adding a positive 18 to both sides. So 3x equals 18 divided by 3 divided by 3, x equals 6. So in this case, x equals 6 is right here. And then I'm going to do the same thing, but now I'm going to let x be equal to 0. So 3 times 0 minus 4y minus 18 equals 0. Minus 4y minus 18 equals 0. I'm going to add 18 to both sides. And I get negative 4y equals 18. Divide by negative 4, divide by negative 4. And 18 divided by negative 4. We can reduce that down. That's negative 9 over 2. Might be a little bit difficult to graph, so I'm actually going to divide them to get a fraction. That should help me. And that gives me negative 4.5. So negative 4.5 on my y is right about here. And then I can just, now that I have both x and y intercepts, I can just draw a line that cuts through both points. Just like that. Okay, so if you find yourself with something that you don't want to rearrange, then you don't have to. You can use your x and y intercepts to help you graph. Okay, so but if you are somebody who always likes it to put it in y equals mx plus b form, then go ahead, put it into that form so that you can pull out your slope and y-intercept to graph. It's really kind of up to you, whichever you prefer. Okay, so one of the things that we really want to talk about too is this aligned? So when we look at an equation, what we're looking for to graph is this y equals mx plus b form. And this, if we look at this equation given, does it meet this criteria? So notice I only have one x, but I also, that exponent on that x is a 1. So anything that has a higher exponent than a 1 is not a line. Okay, so just to be kind of wary about that, if you're looking at something to graph and you see that the exponents are higher than a 1, then it is not. In fact, this is kind of a cubic, and it looks like this. Something like that, I think, which you will see a little bit later on as you move down the road in other math courses. So not in grade 10 math, we're not going to examine cubics, but just take a look at your exponents. If any of your exponents are greater than a 1, then no, it's not a line. Okay, so this brings us to the end of graphing lines. If you have any questions or concerns, of course, please reach out and ask for help. Thank you.